in some weird way. This is part of the material that, thanks to Edward Snowden, came to light. So it is not known if it's just a certain department of the NSA or like a summer intern who wrote some slides, or if it's like it represents the full state of knowledge by the NSA about Tor. In this presentation that was shown, they said that we will never be able to de-anonymize all Tor users all the time, but that they can, with manual analysis, de-anonymize a small fraction of Tor users. And I will come back to that later when we look at some of the problems with the technology, some of the issues, and maybe how to address them, and what is likely the way they're de-anonymizing currently. This is a separate set of slides that were also released. And this is a kind of a nice testimonials to say that Tor is the king of high, secure, low latency internet anonymity, and there are no contenders for the throne in waiting. This sort of reflects also my thinking when people say, oh, I've heard Tor has this and that flaw and these and that problems, is that might be the truth, but there's no alternative to it when it comes to anonymity online. At least for now. First of all, one of the biggest problems that I have when I talk to journalists or even ordinary people, they misunderstand the term anonymous communication in the context of Tor. Anonymous communication is not about communication where you are trying to be anonymous. That's what I called in this slide anonymous speech. So it's not about some like chat roulette kind of thing where you meet a random anonymous stranger, because even anonymous is a very hard word. If you're talking to someone online and you meet them regularly and you don't know their name, you don't know much about their identity, you usually have a persistent identifier of that person, and that's pseudonymous. So I guess there's very little interest in communication that is really anonymous, in that sense that you're talking, that you don't have any persistent identifier for the person you're talking to. But even then, Tor isn't really about that. So Tor is about two people who want to communicate. In this slide it's A and B, very wonderful visualizations, I made it myself. And these people, they know each other, or it's a website that you know, and you're willing to identify to that website. It doesn't matter. So one example would be, you want to access your Facebook, and Facebook, you're with your real name on Facebook, and all your friends on Facebook, and you still want to reach that website anonymously. So Tor is about protecting the link, the communication path between communication partners. It's about making sure that from the outside, it's very hard to see who is communicating with whom and when they're communicating. So in the first talk today, Ben talked about post-quantum crypto and how we can secure a communication link, but still by being able to see traffic flowing between communication partners. And we had a lot of news about that with like metadata correlation and analysis, network analysis of people that, I mean, you can probably imagine that there's a lot of stuff you can derive just from knowing who's talking to whom, for how long they're talking, when they're talking, etc., etc. And that isn't addressed by any cryptography. That is what Tor is about. Tor is about, additionally to securing the communication by end-to-end encryption, you also want to make sure that nobody sees the connection in the first place between communication partners. I like this slide because, well, it's about human rights, and I like human rights. And I especially like the wording, and I want to always, especially when I talk to journalists and they confront me with the negative effects of securing communication, making sure that nobody else can sort of monitor who you're communicating with, and et cetera, et cetera. That it's clearly stated here that a human right is to seek, receive, and impart information and ideas through any media and regardless of frontiers. And this, I think, is the main thing that Tor is about. And I want to include, so usually I include Article 20 because I believe in that when you're meeting online and communicating online, it's really about the right of assembly and association. So I think that's also a very important human right, that we don't have to give up when we enter the digital world. Just as a reminder for most of you, I guess most of you have heard about Tor and like the generic concept of it. Some of you may not. So the idea is that you have, nowadays you would call it the cloud. So this is a Tor cloud. This is it's a network of Tor nodes, as they're called in this slide, that provide infrastructure that any Tor user can use to reroute their communications across the internet. So it's an overlay network over the internet. And the Tor client, the Tor user, connects to one of the sets of Tor relays, which is called the entry node, and then makes another connection to the middle node and then to the exit node. And the exit node is actually executing the request and forwards the answer back to the user. As you can see, you cannot see it very clearly here, but obviously there's encryption between these, and there's not very good visualizations. That was one of the earliest visualizations of the concept behind Tor, which is called onion routing, which is that you as a client, you know public keys of all the participating relays. So you can set up what they earlier called a telescope to the exit relay. So you encrypt the traffic that you want to send the data with what is colored blue here, and only the exit relay can decrypt it. And then you encrypt it again with a key from the middle relay, and then you encrypt it again for the entry relay. So if you take the telescope and turn it 90 degrees, you can see it's like shells around the real traffic. So this is what is onion is about. It's like onion. It's like an onion around your traffic, and that makes it possible. So on the entry node, you receive a connection from someone, and you know who you're talking to. So you see the IP address of a user, but you don't know the content of the data. And you don't see the destination address, and you don't see the exit address. All you see is when you remove your encryption layer at the entry relay, you see the address of the middle relay and the traffic you're going to hand to the middle relay. So then you pass the traffic to the middle relay, and they remove their layer of encryption and then pass it on to the exit relay. And then the exit relay, so the middle relay sees only encrypted content, right? They see a connection coming from some relay. They see that they have to forward it to another relay, but it's all encrypted with the exit relay key. So they can't really see, they don't see the user side, and they don't see the destination or the content. And the exit relay, they see the initial request because that's what you want the exit relay to see, because they will execute it on your behalf and make the request or send your data to some destination and get the return content. And I will come back to that because that's one of the things that people always confront Tor people with, is that the exit relay can see the original content that the user was sending. To the practical part, what you have to do when you want to use Tor is you just fire up the Tor browser bundle. You can download it from the website. This is a nice Windows screenshot. It works cross-platform, so there's a Linux build, there's a Windows build, and a Mac build, and you can build it on your own obscure platform if you want to. There's a version for Android. It's called Orbot. Yes. So what happens when you fire up the Tor browser? It's a modified Firefox, because today one of the problems that you have on top of hiding the communication path is that usually your applications that you want to use, they also embed a lot of, or make it possible to access a lot of information from your local platform that you don't want to leak. For example, the screen size, or all sorts of fingerprinting. There's a nice website called Panopticlick from the EFF, where they show you what kind of attributes they can get from your local machine via JavaScript and some other methods to fingerprint your machine. So even across sessions, no matter where you're coming from, they can re-identify you, so track you across sessions. So at one point, Tor decided that because one of the main applications of Tor is obviously web browsing, they had to provide even more application level support to protect against these tracking methods. So at the beginning, we tried to do it via an extension. So you would just install the Tor button extension in your browser and then switch to the Tor mode. It turned out that there's a lot of fingerprinting methods that you can't really access as an extension that you would want to disable. So we're actively working with Mozilla to push all the changes we made into some kind of interface so we can enable it. There's even the process of integrating Tor completely in Firefox. They're very interested in having like a better private mode, because the current private mode doesn't really protect what the user expects to protect. So the current state is that it's not exactly a fork, it's a set of patches that are applied to the Firefox code base. And we're using the extended service release, so we're not using whatever new version Firefox spits out or Mozilla spits out every week. But they have an extended service release meant for large companies that have to redeploy, and they're depending on more stable code base. So they do backport the security fixes, but they don't come with the latest features that nobody really needs anyway. And then we apply, I think at the moment it's around 40 patches to the code base to further protect users from fingerprinting attacks. And this is how it looks like. You can enter your destination address and use it as an ordinary browser. The second approach, or the second most popular use of Tor, is to use Tails. Tails is a live distribution based on Debian, and it comes pre-configured, so any application that comes with it routes its traffic through Tor, and you can't start anything and make connections like without Tor from your machine. So it protects from all sorts of attacks against like you running something that de-anonymizes you because it runs on your local machine and it doesn't use Tor and makes an outgoing connection to something. And also by being a live distribution, you can put it on a read-only medium, and then an attacker cannot modify your local system. And obviously, again, since it's a live distribution, it doesn't leave traces on your machine. So you just boot it, you do whatever, and it doesn't affect any of your disks or whatever you have in your machine. There's a lot of interesting material that I want to show you, but I thought I would start with a number of users from Serbia. There's a website called Metrics that has a lot of interesting statistics on both the network side and the user side. And as you can see, the number of connections coming from Serbia is pretty stable, has been pretty stable over the last months. I didn't go back in time because there were some incidents affecting the calculation, the estimation of users, but this is what we have at the moment. Even when I arrived in the course of today, there was frequently asked questions, people coming up and asking mostly the same questions about Tor. So I thought I would address these comments. So one of the things people always repeat is, since you're making connections via relays and anyone can spin up a relay and basically forward traffic for other people, what happens if I'm a malicious actor and I run relays? So there's remember that there is your entry relay into the network, and a middle relay and an exit relay. So we have to look at all three positions for the problems with malicious relays. And so a malicious exit relay, I already mentioned that a malicious exit relay can see the user traffic and the destination address, but not the source IP. And it can modify, obviously it can modify all the content that it sees. It can modify the request you're sending, and it can modify the answer coming back. The most important things are DNS requests. DNS requests are UDP, and Tor doesn't handle UDP. But for DNS, there's a subset of DNS requests, the most common DNS requests, that Tor forwards to the exit, and the exit is supposed to execute the DNS requests and forward the answer back. It can modify the DNS answers. It can look at HTTP traffic, modify the answer. It can look at SMTP, IMAP, the usual mail protocols, and all the other unencrypted protocols. There were some studies where people ran it and monitored it and looked at the data that was flowing through. And I think still, I don't know about any recent studies like that, because it's problematic if you look at traffic forwarded from other people. You usually lose your legal protection because you're not supposed to look at user traffic. And also ethically, it's dangerous to do too many statistics and to look into packets from other people. But I would guess that there's still a lot of plain text traffic on the Tor network. So this is a real problem. And there is no good way for Tor to address this, because it's the user's responsibility to decide what kind of applications they want to tunnel over Tor. Tails used to tunnel everything you run on the Tails operating system via Tor. They stopped doing that, so now when you fire up any random application on Tails, it just fails, because you really want to have sort of control over what kind of applications can even use Tor in the first place. This is why the Tor browser comes with an extension like HTTPS everywhere, to make sure that, at least for the websites that are known to support HTTPS, you're making HTTPS encrypted end-to-end connections. I like Certificate Patrol. It's an application that monitors the certificates over time. So when you see a certificate change in a website, it displays the change. So when certificates expire at some point, so it allows changes that are near to the expiration date and only displays a small information window, like a bar on top of the browser. But if there's changes in the certificate authority or changes that don't match with the expiration date, you get a pop-up that shows the changes in the certificates. And that's very helpful because even with encrypted connections, if the exit relay is trying to actively play or mess with your data, you can still hopefully detect that. And I mean, that's a big problem for the whole internet, that HTTPS is basically known to have its big problems with the whole certificate authority issues. And we also run scanners across the network, so they run all the time, constantly looking at applying certain tests. So you can't detect someone who is sniffing the traffic, but you're able to hopefully find relays that modify. And it turns out that most of the relays that mess with user traffic that we found were configured to use OpenDNS, and OpenDNS has a filter list, and they don't allow certain destinations. So that's one problem. And a lot of times it turns out to be a misconfigured system, and then you write to the relay operator and you tell them about the problem and they fix it. There's a set of relays that pop up from time to time that are trying like primitive man-in-the-middle attacks that even the Tor browser without certificate patrol will show you, because they use self-signed certificates. But I mean, most users will likely just click and say continue. So it is a big issue. Then when you have a relay at the entry position or at the middle position, as you've seen, it only sees encrypted content. So the only thing that it could do is denial of service, basically, because they can just stop and not forward the traffic. But if they forward the traffic, then there's not much they can do as a malicious relay. The bigger problem, and what people hear from time to time with Tor, the issue with Tor and anonymization of users, is a big research question, basically. The question is, how can you have a low latency anonymity network where you expect an answer to be given back to you in a reasonable amount of time? You want to be browsing the web, for example. So you expect it to return the website in a reasonable time span. So the current way the Tor network works is that the relay receives the traffic, and it either has a connection to the next relay, or it opens a connection to the next relay immediately. And then it forwards the traffic. And then you keep using that path in your client. For the default is for 10 minutes if the exit relay allows your destination connection. So as an exit relay, I can specify what kind of destinations I allow based on IP addresses or ports. So I can block certain ports. I can only allow certain ports. So we have a circuit to an exit relay, and it's stable across the network. So the entry relay has a connection to the middle relay to the exit. And now you're sending data across the Tor network, and you're receiving an answer back. So when I have a view of the network where I can see the traffic both entering to an entry relay and exiting at some point, I can do a statistical analysis just by seeing. There's various studies where they use various amounts of knowledge. For example, if you just have the packet sizes, that's already enough to de-anonymize users. So an attacker that has a view over a certain set of Tor relays can do that statistical analysis, just because Tor can't really delay the packets, because you expect from a low latency network that you get an answer back in a reasonable amount of time. So if you're interested, there's a quite old blog post on the Tor project website, and this is a quote from a very recent study that's been made about traffic correlation, and it's quite scary. So let me just read the highlighted section. An adversary that provides no more bandwidth than some volunteers of today can de-anonymize any given users within 3 months of regular Tor use. with over 50% probability, and within 6 months with over 80% probability. So this study looked at various actors owning or having control or being able to monitor certain fractions of the internet. So attackers that own one AS or two ASs or an internet exchange point, or even larger fractions of the network. So this is a very interesting paper, and I didn't put the address of the direct paper because I wanted to also tell you about AnonBIP. It's a very good and large library of papers around anonymization. So if you're interested in that topic, you should look at that website, and it has highlighted papers, like the most relevant papers in the field. So coming back to both problems of malicious relays and traffic correlation attacks, these are problems of any low latency network that you could imagine to ever exist, right? Because if your goal is to being able to connect to ordinary destinations that don't speak a new wonderful protocol, then you will have someone, you will want to have someone on the network execute your request on your behalf. So in some sense, it's outside of the scope of Tor. But as you can see with the Tor browser, we're starting to address these sort of application level problems, and with HTTPS everywhere and things like that. I mean, we're all hoping for end-to-end encrypted traffic to increase, and so hopefully malicious relays won't affect the usage of Tor that much in the future. And it's really, it now sounds like Tor, like every time you use it, you hit a malicious relay. That's not the case. So our scanners find one in like every 2 or 3 weeks. So it's not really that big of an issue. And the traffic correlation attacks, as you can imagine, any kind of technology that just forwards user traffic and sends back the replies is affected by this problem. The naive solution would be to send constant traffic, right? So you don't disclose when you're executing requests or how much data you get back. But then your tunnel has to saturate the line at all time, or limit the dummy traffic, and then you can't really use all your traffic. So dummy traffic can help in certain applications, but to deploy it on the whole Tor network, it would just generate too much traffic, because the user would expect some kind of fraction of his bandwidth to be available for requests. And at the same time, Tor relays have to receive all that dummy traffic constantly from all the users. And with around 1.5 or up to 2 million users daily, you can imagine that the current network wouldn't be able to handle that traffic. And then there's a lot of interesting studies that looked at this, and it's not even it's generating dummy traffic and making sure that like the line is filled is not a trivial problem. Another thing that you hear regularly is that some entity, some government entity or whatever, runs like a large fraction or some fraction of the network, and that this is the reason why people are not using it. There's variants of this this statement, and for the question is, what would they gain by running relays? And for a traffic correlation attack, that's a passive attack. As long as I can see the traffic flowing into that relay and the traffic exiting that relay, I don't really need to run any part of the infrastructure. And then the other thing is a personal thing. Me and many other people at Tor, they build relationships with relay operators. They know a lot of relay operators, and we keep a close watch on who is running what fraction of the network, who's behind that, who is the guy behind that. And then the third thing I usually say is, It would actually be nice, because then we wouldn't rely on people like me to run relays. It would be nice to have competing agencies run relays for us, because even if you run like a fraction of the relays, there's still the traffic correlation attack, but you can do that without running relays. If you just run like the entry relay for that connection, then you don't really gain anything other than providing free bandwidth to all Tor users. And if you run an exit relay, you also strengthen the network for all Tor users, because even when you run an exit relay, all you can see is the destination and the content. You can't see the user IP address. So coming back to that this is a general problem, I always ask, what do you trust? And then a lot of people say, yeah, I have this VPN provider that I trust. And even some people, they know the people that run the VPN provider. But in the end, the VPN provider can be much more dangerous than a Tor relay. Because they see both the user connection and they see the content, and so both problems apply very hard also to VPN or any proxy. And if you're worried about the traffic correlation attack, obviously VPN is not going to help you. And as we've seen from some NSA slides, they kind of seem to have some more or less automated way of de-anonymizing VPNs and proxies. I don't know too much about it. The slides didn't really say, but some slides hinted towards that capability. So let's look at the Tor network, because on the one side, Tor is a software. It's even more than one software. It's a Tor browser, it's the Tor client relay program, and then there's a lot of other tools. And on the other hand, there's the network. And when you see like this picture of stable relays running, you would say this is a quite healthy network. Looks okay, there's some centralization, but it's quite distributed. Then if you look deeper into it, and if you look at the fast, if you remove all the very slow relays that are not really helping much to the network, then you end up, at some point, looking at this map. And this is exit relays that pump more than 1 megabyte per second. So these attract the majority of the users. And then you see it's not a very happy network. So that's mostly my area of interest, and where I'm active is trying to teach people about how to set up relays and run relays, strengthen the network, help other Tor people, both in like how to actually run a relay, and also in trying to make people aware of it, obviously. And so what I started, let's look at some other tools that are interesting, because as I said, I'm advocating for people to learn more about Tor, and people always come and say, how can I help? And in the case of a non-technical person and they don't know how to run a relay, or they don't want to really do it, there's also other ways to just explore the network and learn about it. And what we at this point can use also for advocacy and journalists would, for example, be visualizations of the data. So that's why I want to present the current state of both the data and some of the visualizations we have. So you can learn from the data, but you can also learn that our visualizations can be vastly improved. And so if you're interested in programming, this would be one area where you could just look at visualization methods and take our data. It's all publicly available, and play around with it. Compass is a less known tool in the Tor community. That's why I have it here. it allows you to filter all the Tor relays in the network and only look at certain relays. But the interesting thing is the group relays by country and the group relays by AS. And then you can look at the distribution of Tor relays based on the fraction of traffic that a certain country provides for the Tor network. And enter like Serbia and look at all the relays in Serbia. And this is the answer to a request that asks to sum up all the countries and then show each country and the total probability. So there's some columns here, and I marked the exit probability. So this is the probability of a client to exit in that country, right? And as you can see, it's not very evenly distributed across countries. Most of the traffic at the point of the screenshot, like 30% of it exited in the US, and then there's 11% Sweden, 11% in the Netherlands. And this is just the top 7 on this screenshot. So as you can imagine, one of the things we're looking into is how can we attract relay operators in other countries? How can we find ISPs in other countries? And the same for the guard probability. I didn't talk about guards much, but you can roughly say that's the entry probability. So when you fire up your client, in 27% of the cases that you're using it, it will connect again to some relay in the US. And in 22% of the cases, you will end up in Germany. And when we go back to the major known attack against Tor, that an adversary that can see the traffic at the entry point level and at the exit point level can de-anonymize users, you can imagine that strengthening the network is really important because obviously if you're very evenly distributed, an attacker has to be very powerful to see this traffic. And this is not the case, as you can see from the slides. This is a screenshot of the Metrics website. I want to show it, hopefully, if my connection is still up live. I mentioned this before. So here you can look at the state of the network. I won't go into detail, but you can click around yourself. The bandwidth and there's a nice bubble graph about the distribution of relays per country. I don't know if it loads here. Yes, it does. So as you can see, this is Germany. It's just another representation of the data that I showed you in text format: Netherlands, France, United States. And yeah, that's not very evenly distributed. And the major reason I'm showing you this in a bit more detail is that Metrics and Compass all use the data provided by OnionU. OnionU is fairly new, and it's an abstraction away from just using the raw data that Tor uses to generate some visualizations. So it sits between the raw data and the visualization, the metrics and Compass, and it's a simple JSON API you can query, and it has a lot of stuff that you can simply query. I can show you one. So yeah, now that I'm using live internet, it's always a danger. But you can see that, for example, for the relays, you can get an array of the flags that are assigned to the relay, the country name, region name, city name, if it's available, the AS number, so the network it is located in. And so there's a lot of interesting data available, and that's why I want to show this, because people are really aware of this. They only look at the outcome, like Tor metrics, and rarely at the back end. So if you're capable of like programming against the JSON interface, you can just look for interesting data and analyze it. This is from the blog, so it's a call for front-end web developers for Atlas and Globe. Atlas and Globe, I can show you, are, let's use Compass, for example, to look at Serbia. And I won't select any of the other options, so I'm selecting all relays here. I'm not grouping them, so I want to see all the relays here. And this is the state of the network in Serbia. So now probably you can imagine why Miloš is strongly trying to find more people in Serbia to run relays. There's not much bandwidth here. There's on this current network there is no exit in Serbia.
No, it's not true. It's not true.
That's the current state of the network.
No, number four.
This?
Raspberry Pi node. It is exit.
So yeah, that's what I want to show you. This is.
I just need to clarify.
Yes.
Serbia has no exit.
It does.
Okay, so this is Atlas. This is one of the applications that we're looking for people to work on. Globe is very similar. It displays information, more detailed information about single relays. So you see the exit policy. And as you can see here, this relay allows exiting on certain ports, like 25, 1110. So this is plain text traffic. This is encrypted traffic. This is HTTPS. But Tor doesn't qualify. This relay doesn't qualify as being called an exit because the exit status in the network is tied to certain ports that you have to allow. And one of the ports is port 80. If you don't have the exit flag, that clients are very unlikely to use you for any exiting. So in some sense, both are true. There are some exits and there are no exits because they're not really very helpful unless they get the exit flag.
I've been running that node for maybe 1.5 years, and in the meantime I've reinstalled it and I forgot to back up the keys, so there's not whole history.
Yeah.
But when I enabled port 80, because it's Raspberry Pi computer, I guess the crypto is too hard for that and it starts to drop packets. So
Yeah, that's.
disable port 80.
Yeah, but by disabling port 80, I mean 80 is just HTTP traffic. But by that you remove the exit flag, so you don't get the traffic, and obviously then Raspberry Pi is strong enough to be a relay.
Should I
But-
just disable like just to be in middle level?
No, it's fine like that. You can leave it like that. It's just the Raspberry Pi is not really suitable to contribute much. It's nice. It's a nice experiment and a nice little box. All this data is available from OnionU, from the jQuery, the JSON interface, and Globe. Globe is very similar if it loads. Doesn't like me. Anyway, so if you're interested in helping and visualization of data, this is what you want to look at. There's another recent call to arms. It's about a fellowship program that is available at the moment. So you can apply for working on a specific aspect of a problem we're having, namely the problem that a lot of websites start using third-party block lists or services like Cloudflare. And these services, they just take any IP address, and when they see abuse coming from that IP address, they block that IP address. So a lot of exit relays are blocked from certain websites. And there's interesting research, there's a lot of proposals on how to help operators of websites avoid having to block Tor users completely. So this is a very recent, August 29 was released. Doesn't load for me. It doesn't matter, it looks, it should take the same query strings. I wanted to show the difference. I can take this. So this is Globe before we saw Atlas, but it's basically the same. It shows the information about the relay and the exit policy and the flags it has. And yes. So this might be very interesting for someone who understands enough about technology, but it's less a technology problem. It's more about providing the right information, or maybe, for example, one could imagine that for popular content management systems that we would develop plugins that help you categorize your users and say, okay, a Tor user, all comments coming from Tor users are going into moderation, because that will help against people trying to fill your blog with stupid comments or stuff like that. So it's not an all or nothing decision. Usually you can classify your users into certain like danger groups, and that's also interesting outside of Tor, because just using the IP address and blocking all users from that IP address, obviously you can imagine that this is a larger problem than just for Tor. So in general, the blog is a very interesting website to have in mind and to stay up to date. You might want to subscribe to that. Here I have opened the AnonBib, the selected papers in anonymity that I mentioned earlier. So it goes back to 1977 and it has a lot of papers. So if you have some free time, like just dedicated it to this website, and then you will know everything. And as you can see, there's some highlighted papers here that you might want to look into. Okay. So I already mentioned that my focus at Tor is to look at the network and try to help diversify and strengthen the network, both by providing more bandwidth so it gets faster, and by providing more diverse network so it strengthens the anonymity. So this is a project I started. It's called torservers.net. And it's all about operating relays. And in 2010 I started doing this, and I started a call for like, let's run an exit relay together. So if you want to chip in and give me some money, I will run a large relay. And after half a year, I had like almost 80% of the exit capability of the whole network. That wasn't a good thing, because one person shouldn't be responsible for a large fraction of the network. And back in 2010 it wasn't as popular as now, so we managed to also find more and more people. I started to call it like franchising, because I was speaking at a lot of conferences with a lot of people. So now we're 13 organizations, because you also want to have legal and operational diversity. You don't want me to be able to access all these relays. And Benfix was very helpful, the Holland Foundation was very helpful. And now we got a grant from HIVOS, it's a Dutch foundation, to further strengthen the network. And this is like a summary of whatever interesting things that I could imagine would be interesting for you. There's a very good email newsletter, it's called the Tor Weekly News, that you can just subscribe to, or you subscribe to the RSS feed that will help you keep up to date, learn new things about Tor just by reading an email every week. It's very good. Then the AnonBib, I mentioned, the blog altogether. The blog has the Tor Weekly News and more. So if the Tor Weekly News is too little information for you, subscribe to the whole blog. And then the real way to get involved in Tor is to be an IRC. Everything is happening on IRC, and these are the major channels that we're using. So the Tor servers channel for relay operation. It's the dev channel for code development. This is a fairly new Tor-Dash project is a fairly new channel. It's for everything around the project, the website, whatever, except for coding parts. So this is a very interesting channel also if you just want to understand the community more, get to know the people. This is where you want to be. And then there's Tor. It's the regular channel that is now mostly for like user interaction and user questions. And a very fun channel to be in sometimes is not Tor, because there you are allowed to talk about everything. But it's still somewhat close to Tor. So people post random links, random cat images, whatever. Sometimes you can't read it for days because there's some people on there you don't want to really waste your time on. But it can also be very interesting. So I invite everyone to, if you want to stay in contact, to use IRC. Then there's all our mailing lists. I guess you can find them. And then at the end, this is my email address and my fingerprint. You can't really read it, but as a reference, some of you took pictures. So yeah, this is my talk. Thank you. We had a question here.
Tor user be tracked by random user?
Well,
Could Tor user be tracked by random users?
by what? By what abuse?
Random user that's not using Tor.
What do you mean by being tracked by?
To find his real IP address and
So, what you see at let's say you're a website operator and you want to identify a user, all you see is the exit IP address. So there's no way to see the real IP address. That's the purpose. And then you would have to go back the whole chain of the network to be able to find out who was the user. Yeah?
Me?
Yes?
You sure?
Yes.
Okay.
The lawyer, please.
Yeah.
when you showed the graph of usage from Serbia, you censored the graph, saying before there were some kind of something. I'm not quoting you. The quote would be, there were some incidents that prevented me from showing you this.
I mean, it's all online. It's not. I mean, censoring would be to stop you from getting that information. Yes. Users. We want user graph.
The point is, could you give us the correlation in between?
So this is directly connecting users in all countries. So this is not only affecting Serbia. This was a botnet jumping on Tor. So it used Tor as a backup plan for communicating with the command and control server. So it doesn't look like they actually used that backup channel to communicate with the botnet, but they added it. So they rolled out a Tor client to all botnet clients, to all clients infected by the botnet. So every computer that was part of the botnet started to run a Tor client, and Tor makes connections, even if you're not using it, preparing connections So it's faster if you start using it. And this is what you can see here.
I was more, my question was more directed to certain political developments in Serbia and correlations in usage.
I don't know. I mean, I'm not an expert about Serbia. You are, so maybe some of you are. So we're always interested in learning. But you can see the graph from Serbia is very much very similar to the graph of overall users. So I can't really see that much of a spike. We can maybe look. We can zoom into detail here, but we can.
It appears that no real users are using the network. Before nobody was always using. Those are all bots.
So that's a valid point. Is that we don't know how many bots are still out there. So Microsoft was leading an effort because it was all Windows. Microsoft was leading an effort to kill the whole botnet. And they released a statement where they said they more or less killed the whole thing. But you're right, it doesn't, even from the overall users, it's very hard nowadays when people ask us how much users do you have on your network, because we lost the ability thanks to that stupid botnet.
Microsoft came and deleted the Trojan from Windows PCs, but they left the Tor exit. The Tor client, they left there.
But it shouldn't be started.
It shouldn't be started,
yes.
but
Yeah.
maybe they didn't prepare the registry. Maybe it's starting every day because that is they removed.
They managed to remove a lot. So
a lot. They
yeah.
removed a lot, but they didn't remove all.
Yeah.
Thank you.
Those are really not users.
It is possible that Tor user trace his packets through the Tor to the exit. His own packet.
Yes, because you define what kind of traffic you send into the network, but you also know what path you're taking. So as a user, you know already the path you're taking. There's no necessity to really trace anything because you built the path as a Tor user. And then you can inject traffic, obviously, and yes, you can sort of trace it, but you already know the exit relay.
And something else. The servers that access only in Tor network with only a domain.
Yeah.
Traffic to that servers. That traffic go to exit node and then back to the Tor, or how encryption go?
I didn't talk at all about .onion or the hidden services that Tor supports. So there was a research there was the funny idea that you could also hide the destination by just the Tor user makes this connection, right, to another server outside of the Tor network. But you can also use this backwards, and the simple approach to this would be to just use a rendezvous point, a point where you meet your users. So you can imagine, like you can think of a hidden service as the same like a user, but it keeps asking some point in the network for users, and then they connect. So you have a user protected by 3 hops, and you have a hidden service that more or less also uses 3 hops, and they meet in the middle. That's a very rough and it's a lie. It's not the real explanation, but that's hidden services. So hidden services try to hide the destination address, so you can run websites anonymously by using the same strategy and putting the server behind the 3 hops, and you have in the middle you have a point where you meet and exchange information. I wasn't enough time to talk about this whole darknet thing that a lot of people are interested in.
Is Tor always using one node, or is it possible for it to use more nodes?
You can configure it for more hops, but it's very much discouraged. And as a relay operator, the new default is to reject this. So the problem is that it puts additional load to the network, and it doesn't really provide any benefit in anonymity. because the only real attack in this is if you're seeing the entry connection and the exit connection. You don't care about the middle. You can put in a lot of hops in the middle because you're just doing a statistical analysis at the entry point and the exit. So it doesn't really help anything other than that it fills the Tor network with more traffic.
I have two short questions. First, I like to watch the Daily Show with Jon Stewart, but they canceled the show in Europe, so we can't watch it online. So they want us to have a different address, if you know what I mean. And I'm wondering, can we use this network to disguise our location and to say, oh, we come from USA?
So the biggest problem is if people like you should have asked only your question and not why you want to do it, because I'm not allowed to tell you how you can infringe copyright or avoid. So we have lawyers present. It's
Will you be so kind and apply Article 19? Of the civil rights that you quoted.
they're not laws.
What? Sorry, that's over law. I'm sorry. It's not copyright infringement if you say I'm not from here, I'm from there. Because the freedom of movement Article 15.
Yes, he can.